software I'm going to show you, it takes an input CT images, which is DICOM, which is standard format, and takes STLs or IVs files, which is standard format as well. So let's get started. On the desktop, you should find an icon called imf.exe. And if you just double click on that, okay. So the first thing you see when you double click on this is like two options, add to database or predict, okay. And the difference, did everyone get this? No? Yeah, the computer is a little slow, like, so be patient with what we're going to do, because these computers are slow. Everyone have this message now? Okay, so these are the two modes that we can run in. So the first mode, which is add to database, which is basically in this mode, you will need the CT data, because then we will acquire soft tissue thicknesses along with bone thicknesses and some measurement. And in the prediction mode, you don't need the CT, all what you need just the IV file or STL file for the surface model that you segmented before. So we prepared the tutorial to you. The tutorial talks about the prediction and to give you just a general overview on what we're going to do. There's some might be some specific details that is different, but I'm going to start first with the add to database mode, show you some of the visualization and the CT, and then we're going to go do a full run for the predict mode. Okay? So what you see here is pretty standard screen that like what you saw in Amira, but there is, so you have the three screens and each screen corresponds to a different plane. So you have the axial, sagittal, and coronal, and the bottom one is a 3D volume view. So the first step we're going to do is if you click load volume, okay, and then it will ask you to browse for your folder. So on your desktop, if you go to workshop material, M64, DICOMs, just click on the DICOMs folder and hit OK. Okay? I guess you can't see it from here because of the resolution, but you should be able to see it on your screen. If you go on the viewing tool, you'll find like few sliders. So the two bottom sliders, these are correspond to the window level and the window width that Dr. Mahfouz spoke about yesterday. You remember in the CT? So let's move the slider window level to the right, and you can see like how it changes your rendering for the image. Do you see that? So this 3D viewer, it gives you an option to see either the slices registered together, and this allow you to see like some of the anatomical features in the volume, and you can manipulate each view by changing the slider corresponding to it. So you can move this axial slice up and down, and you can look at the features by moving the axial slider, okay? And you can move the sagittal the same way as well. And you can see how it's registered with it. So this is one viewing mode, okay? So if you click on the other button here, that switch from this mode of rendering to another mode of rendering is what we call surface volume rendering. Okay, so everyone, if you click on the bottom up there. Okay, so what you see here is actually a volume render of the CT volume. So you can actually, if you put it all the way, you can see, only what you see is a block. If you keep moving, you can see, get rid of the soft tissues, and you can see the bone. Okay, so that's the effect of the window level we spoke about before. Okay? All right. So as I said, I'm just gonna, this part I'm gonna do it on my computer. You don't have to do it on your computer because it might be a little slow. But I will show you how we collect points on the carenia and we add this point to the database, okay? And then we'll go through the rest of the tutorial on your computer. So in the profile tool here, these are the tool sets that allow you to load the segmented model, the template model with the fiducial marker on it, and then picking points on this to get the skin thickness and the bone thickness. So we're going to start first with loading the model, okay? So we load the segmented surface.iv, and what happens is it overlays the model on top of the volume. So you can see here the segmented model and the volume as well. And then we're going to load the base mesh, which it's under workshop material. There is a file called baseskull.stl, okay? And once you open this, it overlays the base skull on top of the other skull and registers them together, okay? So the green one is the template skull that had the 32 fiducial markers, and the white one is the bones that you just segmented in the previous session, okay? And they are registered together so that it shows you where are the location of the fiducial to help you to pick, to do your point selection, okay? All right, so the first step we're going to do is picking the bone and soft tissue thickness at the 13 landmarks that we use. There is a file on your desktop, if you can open it, called landmark. It's a picture file. And this file shows you the 13 locations that we take the measurements at. Okay, so the first one is supraglabella, glabella, Nasian, end of nasal, the chin lip fold, the beneath chin, lateral orbit left, suborbital left, supraorbital, frontal eminence left, the supraglabella, and zygomatic arch midway left. Okay, so the software allow you to pick the points on the surface model at these landmarks, okay? So the first thing, if you go to the profile tools and hit pick, okay? So what's going to do is just switch back to the other mode. Okay, so you can go and highlight points on here, okay? And it display for you the X and Y, Z locations of these points, okay? So the reasons we are picking areas, not just a landmark, is if you pick a landmark, you introduce more inter-observer error. But if you have a selected area, this will reduce your inter and inter-observer error. And then we calculate the average bone thickness and skin thickness at this area. Okay, so once you select these points, you can see them here. Okay, if you hit the profile button, so what the software does now is go and calculate the bone thickness, the skull thickness at these points, and using the volume data, it creates, calculates the skin thickness, and it displays for you down here. If you look here, you see lines, right? This red line is basically the distance from the skull surface to the skin. Okay, so if we go back and to the viewing tools and overlay the volume on top of that, and let's play with our so you can see where the end of the skin hits the line. Okay. Oh, it's too dark. Let me try to. Can you see it now? Yeah, so the red lines is basically the lines from the skull bone to the skin surface. Right here. Everyone see these lines? Okay. And also if you go here, there's a profile tools, and you hit plot. What you see here, this arrows that are moving, is basically what we call a line profile. You remember when Dr. Mahfouz showed you a picture of the phantom yesterday and a line drawing the phantom, and then you saw this graph? So basically this is the same idea, but this graph starts at this bone surface on the skull and ends at the CT volume. So you can see here, this is where the beginning, where the red dot is, and the end is where the white dot is. And then after this, you have black because you're outside the carenia volume. Okay, and you can switch between them to see. Okay, and once you hit the profile button, what you will see here is you will see each point, and you will see the bone thickness and the soft tissue thickness, okay, at each of these locations. All right? So basically, we calculated the data at this landmark, and if you hit save, the program will come up and ask you which landmark it is, okay? So this was at Nasian. So if you hit Nasian and click OK, so you'll find it disappear from here, and it goes to another tab at the end called landmark. And basically, the program saves in the database the landmark and the average bone thickness and the average soft tissue thickness. So that's what you see here, okay? And then you keep going on the 13 landmarks and save this to the database, okay? So this is the only difference between this mode and the prediction mode is in this mode we load the CT, and then we're going to go through in details in the other mode. So if you can close your program actually and open it again and go to the other mode, the predict mode, and let's go through the full exercise. So the first step we're going to do is loading the segmented bone model, all right? So if you go to your desktop, workshop materials, M64, you'll find a file called segmentedsurface.iv. So let's load this file. And then the next step is loading the template model. So if you hit load base mesh, everyone click on load base mesh, and you go to workshop materials, find a file called baseskull.stl. Okay? So everyone open that. So now we should see the green model on top of the white model. Everyone has this? All right. So this viewer has, you can rotate your model around and look at it. You can change the transparency of the green model so that you can look underneath it. The other slider will make the white model, which is the model you want to predict, transparent. Okay? So everyone can do this? All right. Okay, so once these two are registered, now we are ready to go and get our measurement and the bone thickness at the locations. All right, so let's start first with bone. Let's start with the bone measurement first. So on top here, you will find two icons, one called volume analysis and the other one which has a ruler called anatomical analysis. Okay? Do you see these two buttons? So if you hit on the anatomical analysis, you will go to a totally different view with more tool sets. Okay? So on the side here, you'll find two tool boxes, one called measurement and one called landmark, and one called points. All right? So these are the three that we're going to be using today. So the first step is, in our model, we use we use 5 measurements. Okay, so the first point we're going to acquire is an Asian point. Okay, so in order for you to do that, click on the points text and click on, if you, it's on way on the bottom. If you click on it, it will expand it, and then you should see a set of tools here. Everyone has this tool? Okay, so if you click on the first circle, if you click on this, okay, so this will take you to a mode where you acquire points on the skull. Okay, so the first is, in this mode, you will require your escape button, because you might want to rotate, so you need to switch from the arrow to the hand and rotate. And to acquire the point, you need to be in the arrow mode, so you need to press escape again. Okay? All right. So the first thing I'm going to do is I'm going to go acquire the Asian point. So if you click on the area where the Asian is, this takes a point. If you think it's wrong, you can select it, and it will be yellow, and just hit delete. Yes, see this? Select it, it will be yellow, and then hit the delete button. And then you can go and select it again. So now we want to save this in the database as Asian. Okay? So if you click on the table here, left click, and then did a right click, and then click Save to the database. Okay? So the program is going to ask you for what is the landmark name. So this is what we call the combo box. I'll give you a selection. So if you hit the arrow here, okay, and select Asian, you can see also that 3 other landmarks will be acquiring, which is Bayesian and Procyon. So let's hit Asian and click OK. So you see the program took this landmark, the point, and made it a landmark, so it made it a big green circle. All right? And now, if you hit the landmarks tab, if you hit landmarks, you'll find the landmark defined called Asian. Okay? You can move, you can hide and show this by selecting the arrow here. See the checkbox here? You can hide and show the landmarks. All right? Okay, so let's now go and select our Bayesian. Okay? So if you hit the points tab again, and then in the table, select your point and hit the X here to delete it. So now let's go find some Bayesian. It's under here, under the server. So we need someone didn't do a very good job of separating here. This guy actually has a fusion, so you can see there is. So I will select it. I'll select it here. Sorry, no. Okay? So we're going to do the same step again. Once you selected your point, right-click on it and say Save to the database. And in this case, we're going to save it as Bayesian. Okay? So once you do this, you will find another green dot down there. Okay? You might not be able to see it. So you can go, if you hit the Models tab, and then you see a slider here called Transparency. You can actually make it transparent. You can make the skull transparent and look at it. Okay? So you can show it, and even you can hide the whole skull and just look at it. Okay? All right. Okay, so now let's go select the last one. So the procyon is usually the most anterior point on the mid-ridge here, right? So you can see here, you can't see it very well. Okay, so now we're going to do the same thing, save to the database, and save it as procyon. So now you can see 3 landmarks. You should be able to see 3 landmarks. So everyone sees these 3 landmarks? Everyone has them? All right. So now you can just go to the measurement tab again, and you hit, there is a 4 buttons here on the bottom. The last one called calculate default measurements. And if you hit just this button, so the program is going to go and calculate for you the 2 measurements we do using these landmarks, okay? Which is the Bayesian-Bayesian and the Bayesian procyon, okay? And you can see here, it displays for you the 2 measurements and the values for these measurements. So everyone at the same point now? All right. So now we need to go get 3 more measurements that we use in the prediction. Okay. So let's get the transparency back to the default value. Okay. So if these 2 measurements, for the program to show them to you, it makes them like transparent, make the model a little bit transparent. So if it annoys you, you can just go to the measurements and disable them by unchecking them. So this just like removes them from the display. They are still there, but it doesn't display them. Okay? All right? So the 3 other measurements that we use is the nasal breadth, okay, and the orbital height, okay, and then the biocular width, biocular breadth. All right? Okay, so first, for you to do these 2 measurements, if you go to the measurement tab, hit measurements again, there is a set of tools here that you can get measurements with. So the first one is getting line measurement. The second one is getting an angle measurement. Okay, so in this case, we just want to do a line measurement. Okay. So right now in our model, we have the left orbital height. That's what we use and approximate the right with the same measurement. So we're just going to acquire the left orbital height. Okay, and to do that, go and click on the ruler. Okay, and then you will need to click 2 times. Click on the first point, and then while your hand is still on the mouse, drag your mouse down. So click, and then drag, and then release once you hit the other point. Okay, so hit the first point, and then keep your hand on the left button. Then once you reach the second point, just release. And it should pop a dialog asking for the measurement. Okay? So when you do that, if you open the combo box here, you will see the name of the measurements. So select orbit height left and click OK. Okay? So do the same thing. Okay? Everyone gets the nasal breath? All right. So now the last one, which is biauricular breath. All right? Okay. All right, so for me to get this measurement, there is a button here. If you right click and show decorations, right click on your viewer and say show decoration. Okay? And this will show you a tool bar here. Okay? Okay, in this toolbar there is a little box down here. Okay? So what this box do is it switches between isometric and orthogonal viewing. Okay? So let's make it orthogonal. Right click on the viewer and say decoration. So did everyone see this orthogonal view? So now you can go and hit one end, and you can keep moving to see where is your minimum distance is. Okay?
So isn't it diagrammatic breath? What do we?
What's that?
We're doing biauricular breath.
Yeah. So now let's go get some bone thickness measurements. So if you go back to the other tab, the volume analysis, if you open the image, you can see what landmarks we need to acquire. So let's start by the supraglabella. And we'll go glabella, nasal, end of nasal, and so on. Okay? So you can, as I said, you can change the transparency of the model, and you can see where the fiducial marker was on the base skull. And this can help you to add the landmark points. Okay? All right. So once you know where you want to put your landmark, you go on the profile tools, click on profile tools, all right? And then you're going to click pick. Okay? All right? And then basically you will go and select an area around the glabella point. All right, so once you have this, if you click profile, see the profile button here? Click profile. It's going to take like a few seconds, and it should come back with a bunch of measurements here. All right? Okay? And then it will come and ask you what's the name of the landmark. So you select supraglabella. And in this case, it will go to the other table, which is called landmark. So you can see here there is different tabs down there. So if you go to the one called landmarks, you will see the average bone thickness at this landmark. Okay? All right. So I'm going to go and select the rest of the landmarks. All right, so you guys know how to select the landmarks? Yes, I will do one more time. So let's get the Let's get the glabella. Okay, so click pick. Okay, and then with the left mouse button, keep pressing and select an area around, or you can just click one by one if you want. Okay, and once you select all of them, you click on profile. Okay, and then it's going to go calculate the distances. You click save, select the glabella, and it will go to the landmark table. And as you can see here, the skin thickness is 0 because we don't have a volume, so all of them are 0. So we're only collecting bone thicknesses.
So the end of the nasals is a bunch of points, a point cloud, not a point?
You can just take a point there. Yeah, you can take a point there, that's fine. Okay, if you don't know where the landmark is, basically what you can do is you can go to the base model slider and play and change the transparency, and then it will show you again where the base model is and where the markers is. And that's going to help you pick where it is. So you can pick one, and then once it disappears, you can go back and move the slider, and then you can pick again. So once you get your 5 measurement and your 13 landmark, so all what you need to do is just, there is a button here called predict soft tissue. So just hit this, and it will give you an answer. Okay? So basically, when you hit your predict soft tissue, so it will give you the soft tissue thickness at each of these landmarks, okay, in millimeters. All right? What? So basically, like, these thicknesses is the same as if you got this measurement and went to the table. So there is the model. There is 4 parameters here that the model can take into consideration, and if it's not available, it just ignores them, which is the age, the height, the weight, and BMI. So you can go and enter these parameters and can click predict again, and it will enhance your prediction. Okay? So, yeah, you can go and put, I believe this person was 109, weight 109 kilograms, and height 180 centimeters, and the BMI was 33. Yes, it's kilograms, yes. Actually, this tool, it's a more general tool, and we customize this to this program. So I'm going to show you like some other analysis you can do pretty quick on the skull, and then we can end our session with this. So there is other tabs here, as I said, in the anatomical analysis. So one more tool in the measurements that we didn't use in this application was, for example, the angle. Okay, so the angle is basically you go and get 3 points, and it measures for you like the angle between these 3 points. Okay, so this is one tool. There is also a very useful tool that we use under here in analysis in general, which is called contour tool. And basically what it does is it slices anatomy in a certain direction. So actually, let's say you want to look at the cross-sectional of the skull in a certain direction. All right? So if you click on the contour tab, okay, and hit the first button here, okay, it will ask you to what kind of contours you want. So there is 2 modes of contours. You can select contours which is called translational. So it's basically going to slice along an axis, or rotational, which is going to rotate around an axis with a certain angle. So let's, for example, select translation. Okay? And you have to select the 2 points of your axis. If you hit select on the first point, and then select on the second point, okay? And it's going to show you like what is the direction it's going to cut into. And then you define the number of steps or how many planes you want to use. So, okay, so I'm going to cut between these two distances with 10 steps. And if you hit run,
Now, if you were doing this without us here, how long would it take you? I mean, obviously this took way longer than with normal.
like seriously, takes me like, because I know what the landmarks are, takes like 7 minutes with the measurements and the landmarks for a full run. Yeah, and actually right now, like the way this was developed, we had 2 grants going in parallel actually. We had the facial reconstruction grant and we had the skull sexing grant. The skull sexing grant were automating the measurements. So we did the automation for the measurement. And this was going on at the same time. And we needed a tool to collect this data and build the model. But what we're doing right now is merging the automatic measurements we're doing from the other grant with this grant to eliminate the picking points. The difference is that in the other grant, because it's dry bones and we don't take the mandible into consideration, so this is where we're merging the two to get the atlas with the mandible also to get our automatic measurement in it. So, any questions? Okay, thank you.
Thank you.